Before getting into vectors again, let's explore more about matrix and determinant. Here, we got a matrix component. And we will call this a 2 by 2 matrix. As it has 2 horizontal rows and 2 vertical columns, now we understand the basic idea of matrices. Let's move to the idea of determinant. To calculate a 2 by 2 matrix determinant as shown here, we can simply use the cross method. Firstly, draw a diagonal line from the top left to bottom right and get its products. So 5 times 8. Then, draw another diagonal line to form the cross and get its negative products. So negative 7 times 6. Finally, sum them up and get negative 2 as our determinant. Now, let's move to find a determinant of 3 by 3 matrix. We can use the cross method here again. Firstly, draw all the diagonal lines from left to right and get their products. So firstly, 1 times 5 times 9. Then 2 times 6 times 7. Finally take the 3 and times it with 4 and 8. Then, draw the other sets of diagonal lines to form crosses and remember to take negative of their products. So firstly, negative 7 times 5 times 3. Then negative 8 times 6 times 1. Finally take the negative 9 and times it with 4 and 2. Finally, sum them up to get our 0. The cross method for 3 by 3 matrix is quite complicated. So let's try another method, the expansion method. Firstly, we need to obtain a submatrix of the top left component I. So we get this new 2 by 2 matrix here. Then multiply the component I with the determinant of its submatrix. The product resembles some part of our crossing method. Now we finish the top right component, let's move to the next component. For the top middle component J, we can copy our move to get a submatrix. Then again, take the submatrix determinant. But we need to add a negative sign on J when multiplying with its submatrix. As we can see again, the negative product features some pieces of the cross method. After getting the I and J component, let's focus on the last component. For the final top right component K, we can just copy our move again to get the final submatrix. As such, get the determinant and multiply it with our component K. With this in mind, the resemblance between the K product and cross method are starting to show again. To get the final answers, we just need to add them all up. Namely component I with its submatrix plus negative J with its submatrix and add K with its submatrix. As we can see, the final sum is identical to the cross method. In short, it equals to the determinant of our 3 by 3 matrix.